Okay, so in this video, we're going to finish up section 6.6. We're going to be doing carbon dating and then bacteria. So again, this is just application of exponential and logarithmic functions. So with carbon dating, we're actually going to be using a formula you already know. That's our PERT formula. We actually used it up here when we were compounding continuously. Um, the difference is we actually know what the rate is. This is what the rate is always going to be when you're carbon dating. Okay, so let's look at this example. A sample from a refuse deposit near near the Straits of Magellan had 60% of the carbon 14 of a contemporary living sample. In other words, a living sample. Estimate the age of the sample. Okay, so here's our formula. Okay, so what we're looking for is our age. This is the T. The thing is we've got our rate, okay, and we know what it is, but the P and the A we don't know, but that's okay because we know a proportion. Um, P is what what you start off with, okay, so that will be how much of the living sample you had, however many years ago. And now we have 60% of that sample. So the A is going to be 60% of the P. So that is the trick for doing carbon dating. Okay, so your amount that you have, the future amount, which actually is what we've got right now, is the 60%. Okay, then we have E. Our R is given to us up here. So we have negative ln of 2 over 5,700, and then we've got our t that we don't know. Okay, so first thing we need to do is get rid of the p. Okay, and we can do that just dividing both sides by p. So that makes life a little easier. So now we have 0.60, or you could do 0.6 if you want. E to the minus ln of 2 over 5,700 times t. Okay, so again, we want to get that, notice that exponent has the t in it. Okay, so we need to get it down. So the way that you get it down is you take the natural log or the log of both sides. Since we have an e, we're going to take the natural log of both sides. So we'll now have the natural log of 0.60 equals, remember the natural log is the log base e of e to whatever, that's going to cancel out. So we just wind up with negative natural log of 2 over 5,700 times t. All right, so how are we going to figure that out? Well, we need to get rid of this part right here. Okay, that part right there, we need to get rid of that. So we can do that. It's another little trick. We're going to multiply by the reciprocal. So if I put the 5,700 up here, those two 5,700s are going to cancel. Okay, and then I'm going to put this one on the bottom, ln of 2. So that's what I'm going to multiply this by, 5,700 over the negative natural log of 2. So everything's going to cancel out, okay, so that my t, I just have to have that 5,700 over negative natural log of 2 times the natural log of 0.60. And all you need to do is plug that into your calculator. Again, to do that, since I can't show you in person, I'll have that. I'll multiply it by the natural log of 0.60, and I'll divide it by negative natural log of 2. So that's my t. So when you do that, you should get about 4,200.7, if you want to put 0.7 in there, years. All right, let's look at another one. Estimate the age of a specimen and again, it's age, so we're looking for T, that contains 20% of the normal amount of carbon of a comparative living sample. So basically, it's the same thing that we just did, except this time it's 20%. So we've got our PERT formula. So this time it's 20% of P. I still have my same rate, and I'm looking for my T. So do you see how you're going to be doing the exact same thing that we just did? I'm going to divide by P. Now, if I'm doing the exact same problem sort of twice, don't you think it might be on a test? It might be on a test. Anyway, we need to get rid of that E. We want to get this T, right, to be down because it's up in the exponent. So we're going to take the natural log of both sides. So we're going to have the natural log of 0.20, and then that's going to cancel because the bases are the same, they cancel. Minus the ln of 2, 5,700, times t. Again, we just need to get rid of this thing right here, right? So we get rid of it by multiplying by its reciprocal. So the 5,700 is going to cancel out. Negative natural log of 2 is going to cancel out. And we do the same thing on this side. Whatever you do to one side, you got to do to the other. So my t, everything over here is going to cancel except for my t. So my t is going to be 5,700 over negative ln of 2 times the ln, that's time sign, of 0.20. So you're just going to plug that in your calculator. Again, I'll write down what you're putting in your calculator. Times the ln of 0.20. And I just go ahead and put that. And then divide by the negative ln of 2. You may not need those parentheses, but I'm going to go ahead and put it in there. So you should get a time of about, actually a lot of years, 13,235 years. All right, so the very last thing we're going to be talking about is bacteria, the growth of bacteria. Okay, so the concentration of our bacteria in millions per milliliter after X hours is given by this formula. So they've given you a formula. They just want to know how many bacteria is in there after 2.5 hours. So I'm just going to take 2.5, stick it right in there for my X. So B of 2.5 is 1.33. E to the 0.15 times 2.5. And again, all you got to do is put that in your calculator. Make sure when you do that and you put the E, it's going to go ahead and put it up here. And you're going to put 0.15 times 2.5. Make sure you put them both up there. Okay. And then when you hit equal mark, or when you hit enter, it's going to say about 1.94. Notice this is in millions, so you're going to put million. All right. If they want to know after 8 hours, you're going to do the exact same thing, except you're going to put 8 in there. Put the 8 in there, plug that in your calculator, and you'll get that many million, 4.416 million. Now, part C is a little bit different because it wants to know, instead of giving you the hours, it wants to know how many hours will there be 31 million bacteria. So now we know that, let's put our formula here, okay? So we know, so what we're looking for is the X, and what we know is that this is going to be 31 million. All right. Okay, so I need to get this part right here by itself. Okay, so to do that, I've got to just divide. So that's what I'm going to do. I'm going to divide by 1.33. And again, I sort of keep that. That's going to be the ln of 15x, the e to the 0.15x. So now I'm just going to take the ln of both sides. Natural log of both sides. So I'll have the natural log of 31 over 1.33 is going to be equal to, those are going to cancel out, 0.15x. So now I just have to divide by 0.15. So you just need to stick this in your calculator. Of course, the way to do that is to put ln of 31 divided by 1.33 divided by 0.15. So you should get about 21, it's 20.99, so 21 hours. And you do not, need to do the amortization problem in your homework on number 41, you can omit that. I'm not going to ask you anything about amortization. So all you'll need to be able to do is bacteria, and I will give you the formula, um, carbon dating, or the compound interest.